Question 6. Electrical and Electronics Engineering, GATE 2015 Set 2. A three-phase balanced load has a power factor of 0.707 and it is connected to a power supply. The power consumed by the load is 5 kilowatt. The power is measured by the 2 wattmeter method. The readings of the 2 wattmeters are dash. 4 options are given to us. For a detailed lecture on this concept, please refer the NPTEL video, Lecture 31, Connection of Energy Meter, Wattmeter and Three-Phase Power Supply, a course on Electrical Measurements and Electronic Instruments by Professor Abhishek Chatterjee, Department of Electrical Engineering, IIT Kharagpur. Let's understand the working of 2 wattmeter method to measure power. In this method, we have a balanced load whose power consumed has to be measured. We have connected 2 wattmeters W1 and W2 across 2 of the phases. Wattmeter 1 is connected between the red phase and the blue phase. This blue phase acts as a neutral. And wattmeter W2 is connected between Y phase and the B phase. Since this is a balanced load, by KCL, IR plus IY plus IB is 0 according to the Kirchhoff's current law. The power measured by wattmeter 1 is equal to the voltage between VRB and the current that's passing through the R phase times cos phi minus 30 degrees. And the wattmeter reading W2 is equal to the voltage across YB phase times the current passing through the Y phase times cos phi plus 30 degree, where phi is the power factor angle. This is also called as the load angle. Let's see how we got this angle for each of this wattmeter. For this, let us understand the vector diagram of the 2 wattmeter method. Since this is a balanced load and the power supply is also balanced, the angle between the phase voltages of these 3 phases is 120 degrees. The angle between each of these phase voltages is 120 degrees. This thin line is minus VBN, this thin line is minus VYN and this thin line is minus of VRN. Therefore, the angle between VRN and minus VN is equal to 60 degrees. The resultant of VRN and minus VBN is nothing but the voltage VRB, and similarly VYB is the resultant of the voltage between VYN and minus VBN. So this line is VYB. The angle between these two is 60 degree. Since the magnitudes of all these voltages are same, the resultant vector VRB bisects these two vectors. Therefore, this angle is 60 degrees and this angle is 30 degrees. The R phase current lags behind a phase angle of 5, and similarly the BE phase current also lags behind a phase angle of 5, and similarly the Y phase current lags behind a phase angle of 5. The angle between VRB and IR is nothing but phi minus 30 degree or 30 degree minus phi. Either way it is same, because cos of minus theta is equal to cos theta. Therefore, cos 30 minus phi and cos phi minus 30 is same. Therefore, the wattmeter reading W1 is equal to VRB times IR times the cosine of the angle between these two. Similarly, for the wattmeter W2, it is the cosine of the angle between these two, which is 30 degrees plus phi. For a detailed lecture on this vector diagram and how this formula is derived, please refer the NPTEL video that's linked above. In this question, it's given that the power factor of the balanced load is 0.707. Therefore, cos phi is equal to this. So, from this we can infer that the load angle is equal to 45 degrees. Next, it is given that the consumed power is 5 kilowatt. Therefore, the active power is equal to 5 kilowatt, which is equal to the square root of 3 into VLIL cos phi. It is mentioned that this power is measured by 2 wattmeter method. So, we have to find out the readings of both the wattmeters. In 2 wattmeter method, one wattmeter will be connected across one phase and the other wattmeter will be connected to another phase and the third phase will be treated as a neutral. So, both these powers are measured with respect to this phase. For a detailed lecture on the 2 wattmeter concepts, please refer the NPTEL video mentioned above. Therefore, from the given details, 5 kilowatt is equal to the square root of 3 into VLIL into cos phi. Cos phi is 0.707. So this implies that VLIL is equal to 5 into 10 to the power of 3 divided by square root of 3 into 0.707. This is equal to 4083.22 watt. The first wattmeter's reading is equal to VLIL cos 30 minus phi and the second wattmeter reading is equal to VLIL cos 30 plus phi. So this is equal to 4083.22 into cos 30 minus 45, which is minus 15 degrees. This is equal to 3.94 kilowatt and the second wattmeter reading is equal to 4083.22 cos 30 plus 45 degrees, which is 75 degrees, and this is equal to 1.06 kilowatt. So the answer is option A. The answer is option A, 3.94 kilowatt and 1.06 kilowatt.